It's QuarkBeat's time, feel the vibe. Ideas that lift, sparks unite. Like, share, subscribe, don't think twice. You can't deny, let's amplify. Join the beat, it's time to QuarkBeat. Join the beat, it's time to QuarkBeat. It's time to QuarkBeat.
Welcome to QuarkBeat, the grassroots centre for teaching and learning. Follow us on X at RealQuarkBeat for the latest drops and real-time conversation. We're here to spark curiosity, amplify unheard voices, and ignite change through Quark Mind, Quark Speak, Quark Health, and Quark Music. Everything's free, everything's from the heart. Head to QuarkBeat.com for the full experience. Hit subscribe, turn on notifications, and let's join the beat together. Enjoy the video. This is an extract from The Symbolic Species, The Co-Evolution of Language and the Brain by Terrence W. Deacon. It's on page 92, The Symbolic Species, Unlearning and Insight. The problem with symbol systems, then, is that there is both a lot of learning and unlearning that must take place before even a single symbolic relationship is available. Symbols cannot be acquired one at a time, the way other learned associations can, except after a reference symbol system is established. A logically complete system of relationships among the set of symbol tokens must be learned before the symbolic association between any one symbol token and an object can even be determined. The learning step occurs prior to recognizing the symbolic function, and this function only emerges from a system. It is not vested in any individual sign-object pairing. For this reason, it's hard to get started. To learn a first symbolic relationship requires holding a lot of associations in mind at once, while at the same time mentally sampling the potential combinatorial patterns hidden in their higher-order relationships. Even with a very small set of symbols, the number of possible combinations is immense, and so sorting out which combinations work and which don't requires sampling and remembering a large number of possibilities. One of the most interesting features of the shift in learning strategy that symbolic reference depends upon is that it essentially takes no time, or rather no more time than the process of perceptual recognition. Although the prior associations that will eventually be recoded into a symbolic system may take considerable time and effort to learn, the symbolic recoding of those relationships is not learned in the same way. It must instead be discovered or perceived in some sense by reflecting on what is already known. In other words, it is an implicit pattern that must be recognized in the relationships between the indexical associations. Recognition means linking the relationship of something new to something already known. The many interdependent associations that will ultimately provide the nodes in a matrix of symbol-to-symbol relationships must be in place in order for any one of them to refer symbolically, so they must each be learned prior to recognizing their symbolic associative functions. They must be learned as individual indexical referential relationships. The process of discovering the new symbolic association is a restructuring event, in which the previously learned associations are suddenly seen in a new light and must be reorganized with respect to one another. This reorganization requires mental effort to suppress one set of associative responses in favor of another derived from them. Discovering the superordinate symbolic relationship is not some added learning step. It is just noticing the system-level correspondences that are implicitly present between the token-to-token relationships and the object-to-object relationships that have been juxtaposed by indexical learning. What we might call a symbolic insight takes place the moment we let go of one associative strategy and grab hold of another higher-order one to guide our memory searches. What I have described as the necessary cognitive steps to create symbolic reference would clearly be considered a species of insight learning, though my analysis suggests that the phrase is in one sense an oxymoron. Psychologists and philosophers have long considered the ability to learn by insight to be an important characteristic of human intelligence, Animal behaviourists have also been fascinated with the question, can other animals learn by insight? The famous Gestalt psychologist Wolfgang Kohler described experiments with chimpanzees in which, to reach a fruit, they had to see the problem in a new way. Kohler set his chimp the problem of retrieving a banana suspended from the roof of the cage and out of reach, given only a couple of wooden boxes that, when stacked upon another, would allow the banana to be reached. He found that these solutions were not intuitively obvious for a chimpanzee, who would often become frustrated and give up for a long period. During this time, she would play with the boxes, often piling them up, climbing on them, and then knocking them down. At some point, however, the chimp eventually appeared to have recognized how this fit with the goal of getting at the banana, and would then quite purposefully maneuver the boxes into place and retrieve the prize. Once learned, the trick was remembered. Because of the role played by physical objects as mnemonic placeholders and the random undirected exploration of them. This is not perhaps the sort of insight that appears in cartoons as the turning on of a light bulb, nor is it what is popularly imagined to take place in the mind of an artist or scientist. On the other hand, what goes on, quote, inside the head, unquote, during moments of human insight may simply be a more rapid covert version of the same largely aimless object play. We recognise that these as examples of insight solely because they involve a recoding of previously available but unlinked bits of information. Most insight problems do not involve symbolic recoding, merely sensory recoding, visualising the parts of a relationship in a new way. Transference of a learning set from one context to another is in this way also a kind of insight. Nevertheless, a propensity to search out new perspectives might be a significant advantage for discovering symbolic relationships. The shift in mnemonic strategy from indexed to symbolic use of food and food delivery lexicograms required the chimps both to use the regularities of symbol token combinations as the solution to correct performance, and to discover that features of the food objects and delivery events correspond to these lexigram combination regularities. In other words, they had to use these combination relationships to separate the abstract features of liquid and solid from their context of indexical associations with the food delivery events. The symbolic reference that resulted depended on digging into these aspects of the interrelationships between things, as opposed to just mapping lexicograms to things themselves. By virtue of this, even the specific combinations of tokens cannot be seen as indexical, so that it is not just that the ability to combine tokens vastly multiplies referential possibilities in the way that using 2 digits instead of 1 makes it possible to represent more numerical values. Which tokens can and cannot be combined, and which can and cannot substitute for one another, determines a new level of mapping to what linguists call semantic features, such as the presence or absence of some property like solidity. This is what allows a system of symbols to grow. New elements can be added, either by sharing reference with semantic features that the system already defines, or by identifying new features that somehow can be integrated with existing ones. Even separate symbol groups, independently constructed, can in this way become integrated with each other. Once the relationship between their semantic feature sets is recognized, their unification can in one insight create an enormous number of new combinatorial possibilities. The insight recoding problems becomes increasingly difficult as additional recoding steps become involved in establishing an association. For this reason, a child's initial discovery of the symbolic relationships underlying language is only the beginning of the demand on this type of unlearning process. Each new level of symbols coding for other symbolic relationships, i.e. more abstract concepts, requires that we engage this process anew. This produces a pattern of learning that tends to exhibit more or less discrete stages, since the number of combinatorial possibilities that must be sampled in order to discover the underlying symbolic logic increases geometrically with each additional level of recoding. It is almost always necessary to confine rote learning to one level at a time until the symbolic recoding becomes apparent before moving on to the next. This limitation is frustratingly familiar to every student who is forced to engage in seemingly endless rote learning before getting, the underlying logic of some mathematical operation or scientific concept. It may also contribute to the crudely stage-like pattern of children's cognitive development, which the psychologist Jean Piaget initially noticed. However, the punctuated pattern of symbolic conceptual development is a reflection of symbolic information processing and not an intrinsic feature of developing brains and minds. The ability to remember large numbers of potentially competing associations is an additional power of symbolic reference that derives from the shift in mnemonic strategy to token relationships. Competition effects grow in increasing numbers of overlapping associative categories in typical indexical reference relationships. Not only would the choice be alternatives in any use become a source of confusion, but because they were competing for reinforcement, each would weaken the association of the other. Though some of the interreference effects also attend symbolic use and often are a cause of word retrieval errors and analysis delays, in terms of associative strength, there is an opposite effect. Competing sets of overlapping associative relationships on the indexical level translate into mutually supportive higher-order semantic categories on the symbolic level. These become sources of associative redundancy, each reinforcing the mnemonic trace of the other. So rather than weaken the strength of the association, they actually reinforce it. This helps to explain where the additional associative glue between words and their reference comes from. Though token-to-object correlations are not consistently available to the symbol user, indeed are rare. This loss of associative support is more than compensated by the large number of other associations that are available through symbolically mediated token-to-token relationships. In summary then, symbols cannot be understood as an unstructured collection of tokens that map to a collection of reference, because symbols don't just represent things in the world, they also represent each other. Because symbols do not directly refer to things in the world, but indirectly refer to them by virtue of referring to other symbols, they are implicitly combinatorial entities whose referential powers are derived by virtue of occupying determinate positions in an organized system of other symbols. Both their initial acquisition and their later use requires a combinatorial analysis. The structure of the whole system has a definite semantic topology that determines the ways symbols modify each other's referential features in different combinations. Because of this systematic relational basis of symbolic reference, no collection of signs can function symbolically unless the entire collection conforms to a certain overall principles of organization. Symbolic reference emerges from a ground of non-symbolic referential processes only because the indexical relationships between symbols are organized so as to form a logically closed group of mappings from symbol to symbol. The determinate character allows the higher-order system of associations to supplant the individual indexical referential support previously invested in each component symbol. This system of relationships between symbols determines a definite and distinctive topology that all operations involving these symbols must respect in order to retain referential power. The structure implicit in the symbol-to-symbol mapping is not present before symbolic reference, but comes into being and affects symbol combinations from the moment it is first constructed. The rules of combination that are implicit in this structure are discovered as novel combinations are progressively sampled. As a result, new rules may be discovered to be emergent requirements in encountering novel combinatorial problems, in much the same way as new mathematical laws are discovered to be implicit in novel manipulations of known operations. So before turning to the difficult problem of determining what it is about human brains that makes the symbolic recoding step so much easier for us than for the chimpanzees, Sherman and Austin, and members of all the other non-human species as well, it is instructive to reflect on the significance of this view of symbolism for the theories of grammar and syntax. Not only does this analysis suggest that syntax and semantics are deeply interdependent facets of language, a view at odds with much current linguistic theory, it also forces us entirely to rethink current ideas about the nature of grammatical knowledge and how it comes to be acquired. The principles in this reading may be transferred as skills to the learning of the numerological language that underpins English and other languages. Well, I hope you enjoyed that video. We appreciate everyone who watches our videos. Please like, share, subscribe and follow and all that good stuff. For all the latest and every link, follow at Real QuarkBeat on X, because everything's on X. And head over to QuarkBeat.com for the full Monty of our free gorgeous content. Thanks for watching, and I'll see you soon. Bye bye.
It's not just men who can be violent. Women can be perpetrators too, and we need to acknowledge that. It's not just physical. The emotional scars can last a lifetime. Not all of us are perpetrators. Some of us are victims too.
It's QuarkBeat's time, feel the vibe. Ideas that lift, sparks unite. Like, share, subscribe, don't think twice. You can't deny, let's amplify. Join the beat, it's time to QuarkBeat. Join the beat, it's time to QuarkBeat.
It's time to QuarkBeat.